Today we're solving linear systems using substitution. A linear system is two equations with two unknowns, and both of the equations are lines. The first step in solving by substitution is to solve for one of the variables in terms of the other. And both of that is done for us here. Here we have y in terms of x. And they did it for both equations. To do substitution, you actually only need to do it for one. But what we're going to do is we're going to take this value of y, negative 2x minus 2, and everywhere we see y in the second equation, we're going to substitute and plug that in. First we do it. Here we have negative 2x minus 2 is equal to negative 8x plus 4. We're going to isolate the variables, so we'll get the x's all on one side of the equation. Anything you do to the left side of the equation, you have to do to the right. So we're going to do the inverse operation of negative 8x. We'll add 8x to both sides of the equation. You end up with 6x minus 2 is equal to 4. Now we want to get the numbers to the other side of the equation, so we'll add 2 to both sides of the equation. 6x is 6. And finally, we'll also do the inverse operation. The inverse of multiplying is to divide. So we'll both divide both sides by 6 to get x is equal to 1. This is not the solution. This is only part of the solution. This is the x-coordinate of the solution. We also need the y. To solve for y, we'll plug this value in to one of the two equations. If we start with the first equation, we can plug it into the first equation here. And what you get is y is equal to negative 4, and that is our solution, 1, negative 4. It's an ordered pair. When you have two lines where they cross each other, the point at which they cross is the solution. Let's try another one. Here we have two equations, and the first equation you'll notice is not written in terms of one of the variables, so we're going to solve it for one of the variables. We could solve it for x or for y, but I'm going to solve it for x because the coefficient of x is 1, and that will mean I'm not going to have any fractions in my when I solve for x. Moving the 3y to the other side of the equation, you get x is equal to 3y minus 16. So everywhere I see x in the second equation, I can plug this value in for x. In other words, negative 6 times 3y minus 16 plus 5y is equal to 18. Next step is to do the distributive property. Negative 6 times 3y is negative 18y. Negative 6 times negative 16 is positive 96. We'll combine like terms. Also move the numbers to the other side of the equation by subtracting 96 from both sides. And now we'll divide both sides by negative 13 to get y is equal to 6. This is not the solution. This is only the y-coordinate of the solution. You also need the x-coordinate of the solution. To get that, we'll plug the value of 6 in to the second equation, multiply it out, and solve for x. So our solution, our final solution, is 2, 6. You can check each of these by plugging both of the x and the y values into both equations. It's important that you do it to both if you're going to check, because it could be the solution of one equation and not the other. Linear systems, when you have a solution, is where the two lines cross. It's possible that the two lines will never cross. They could be parallel. It's also possible that they could be coincident. That is, they could overlap one another and have an infinite number of solutions. So that's all there is to it, solving linear systems by substitution. Good luck and success.